What's up guys, and welcome back to my little SubaruONLY shop here in Northern California. In today's video, I'm going to revisit how coolant flows through Subaru EJ style motors. For those of you guys who are new to this channel, I actually did a deep dive where I did a whole series of videos walking through how coolant flows through the Shortblock, how coolant flows through the heads, and why you guys might want to consider getting one of those reverse cooling mods that are on the market for any Subaru EJ style motor. That upgrade is a really great upgrade to consider for any EJ style motor, especially for the turbocharged motors, because the number 4 combustion chamber on these EJ style motors actually has a tendency to overheat and cause pre-ignition and damage your ring glands in that number 4 combustion chamber. So for today's video, I'm actually going to put together a compilation video of all those deep dives into the different parts of the Subaru EJ style motor. That way, you guys can have one complete compilation video that shows you all the different facets of this coolant flow through EJ style motors that I looked into. So thanks a lot for checking out the video, guys. My name's Luke. This is the SubaruONLY Show. What's up guys, welcome back to the channel. I got some really cool stuff to show you guys today. We're going to take a deep dive into coolant flow through Subaru heads, and I'm going to take a closer look at the reverse cooling mod kits that are currently on the market. Okay, what you're looking at here is actually a whiteboard image that I drew for one of my earlier videos that walks through how coolant flows through these Subaru EJ motors. And this pretty much applies to almost all flat 4 Subaru motors. And then what you'll see on the bottom here is actually the reverse cooling mod kits that are on the market. This one on the left is the VEMS kit. This is about $90. And then one on the right here, this is from Get a Dom Tune. You can get this from a number of suppliers out there. I know IAG sells them and several other companies out there, or you can get it directly from Get a Dom Tune. So these are both of the coolant mod kits that are on the market, and I'm going to walk through and compare each of these kits in detail at a later point. But before I do that, I want to step back and walk through how coolant flows through these Subaru engines. Because once you have a better idea of how coolant flows through these Subaru engines, and in particular how the coolant flows through the heads of these Subaru engines, you're going to have a much better idea of why you might want to consider buying one of these reverse cooling mod kits. What you're looking at here on this whiteboard is a big radiator here on the front, and what happens is coolant comes out of the engine and goes into the top of the radiator, and then it flows through the radiator being cooled by ambient air, and then comes out the bottom as cold coolant. This coolant right here at the bottom is the coldest coolant in the system. From that point, it gets drawn directly into the water pump, and then from the water pump, it gets pumped through the heads on both sides, and then comes out of the crossover pipe. And incidentally, you also have your oil cooler. That oil cooler also gets coolant, but that coolant for the oil cooler actually comes from the right side head after it's been pre-warmed, and then goes to the oil cooler, and then from the oil cooler back to the water pump. Now that we have a better idea of how coolant flows through this engine, I'm going to take the camera over to the engine and over to the heads, and we're going to take a closer look at how coolant actually flows through all the ports and all the passages on these engines. Okay guys, we're going to take a closer look at how the coolant flows with this EJ205 engine. Now this is an engine from a 2005 US domestic model WRX, and it's a dual overhead cam turbo motor. As you can see, I have none of the timing accessories installed. The left head is off, and the right head is actually installed with that polished valve cover. Now over here on the left side of the motor, that's where the water pumps are installed on these EJ motors. And that's this right here. This is actually the pulley that turns that water pump propeller. Now with the head removed, we can actually take a closer look at where the coolant goes when this water pump turns that impeller and actually draws that coolant that came out of the bottom of that radiator up into the engine, pumps it through that engine so we can start removing all the heat that's been built up in those combustion chambers. Okay, now the first thing I'm going to do is point out exactly where our water pump is. That way, for you guys who aren't familiar with this stuff, you're going to have a little bit better idea of what you're looking at. I'm going to take off this blue painter's tape that I put over to protect it from getting any dirt and debris in it while I'm going through this engine build. This bottom portion right here, that's where your thermostat is installed. So you'll put a thermostat in here, and that thermostat will remain closed until your engine reaches its operating temperature. But once that engine reaches its operating temperature, that thermostat will open, and it will allow that cold coolant that comes out of the bottom of your radiator, enters right here at the bottom of this water pump, and gets sucked in through the impeller and gets pumped through your engine by this impeller that turns from the belt and the pulleys that are on the front of this engine. Now these two nipples right here, these are just little plastic plugs that I have that are covering these intake ports. But what you should notice is the location of these ports. Both these ports are on the outside of this impeller, so both these ports are actually going to have negative pressure applied to them, because when this impeller turns and it starts sucking coolant from this bottom portion and pumping it in through the engine, it'll also be sucking coolant through both of these ports. So anytime you need to tap into these ports, you should know that they're not going to be having coolant pushed out of them. They're going to have coolant sucked through them into the water pump in this direction. And that's important because that's one of the ports that the reverse cooling mods tap into. One of these ports is actually used for our coolant for our turbo to recirculate through that turbo and actually cool some of the turbo heat that's generated. And the other port is actually used for the factory heater core. And those manufacturers that are selling the reverse cooling mod, those guys are tapping into the line that goes to your heater core. Okay, so I've moved the camera position over to more of the left side of the engine, and I've actually rotated this engine to more of the inverse position. And the reason I've done that is so you can see a different angle for this water pump. So here's that water pump, here's a pulley for that water pump, and this big plug right here underneath everything, this plug actually accesses the chamber that the water pump pumps directly into the engine with. So you can actually unscrew this port if you wanted to, and you can access that chamber. Now I'll rotate that engine a little more, and I'll shine a light through there, and we can actually see where that coolant comes in. Okay, here's a close-up view of that port. Now we're looking at the bottom of the engine, and this is actually a passage where the water pump pumps coolant into the engine, and then down through this passage, it goes over to the right side of the engine, and up through this passage, it actually goes up into the left side of the engine. So I can actually shine a light through that port, and that way, it's gonna shine into the block, and you guys can see exactly where the coolant comes into. So here on the left side of the engine, cylinders number 2 and number 4, that light is showing exactly where the coolant is actually getting pumped into the lower chamber of your short block. And what happens is coolant actually fills this whole chamber. And because of the angle right here, that coolant's going to hit this cylinder wall, and it's going to deflect off that cylinder wall up in this direction. Now remember, there's actually a head gasket over this, and then on top of that head gasket is a head. That's going to be the final configuration of your engine. I'll actually grab the head gasket and throw it down just for a second so you guys can see what I'm talking about. Just to remind you guys, right? So you're going to have your short block, you have your head gasket, and then your cylinder head sits on top of that sucker. And as you can see, the coolant is actually going to be going into the short block. And once it fills that whole lower chamber of your short block, it's actually going to come through these holes of your head gasket. But let me remove that head gasket a little further so you guys can continue to see where that coolant is going in the short block. We'll bring that head gasket back in a second. Okay, so let's continue that conversation about coolant entering this lower chamber of your short block. Coolant comes in through here, deflects off this cylinder wall, goes in here, and fills up this whole chamber, right? All this chamber. So you'll notice the chamber right here is completely sealed off. So coolant that fills this lower chamber right here doesn't actually get over to this other chamber right here. This is a solid wedge that extends from the surface right here all the way down to the bottom. It's completely sealed off. So the coolant fills this whole chamber, but only the bottom half, right? Because the engine is actually rotated right now, 90 degrees. So if this engine was sitting in its normal orientation in the engine bay of the car, this whole portion right here would be the bottom portion of your coolant chamber of your short block. And after it fills this whole bottom chamber, the coolant has nowhere else to go but through those little kidney-shaped slits in that head gasket. So I'll bring that head gasket back so you can see again what I'm talking about. Okay, so now the head gasket's back on, and now that we've looked at how the coolant flows without the head gasket, you guys know that this portion right here is completely sealed off. So all the coolant in here is only coming through these ports and these little teeny ports and these ports. These actually are for the head studs or head bolts. So no coolant is actually in here. Coolant's actually only in this portion underneath this head gasket, right? Coolant can actually come through these little ports too. And as a matter of fact, I'm pretty sure that these ports are actually little steam ports. So any air bubbles or any air pockets that are trapped in there can actually escape and get sucked through your coolant system and eventually get purged and evacuated. That way you have a solid column of coolant in almost every port and passage of your coolant system. So this is where most of the coolant will come through, these little kidney-shaped slots, and from here, the coolant will actually pass through these slots and then go into the heads. And from that point, coolant flows through the heads and then back out of these slots and it goes back into the cylinder block. So I'll take this head gasket off without bending it, put it back over there. And just to show you what I'm talking about the coolant going back into this section, so coolant actually exits the heads through those little head gasket slits, those little kidney-shaped slits in those head gaskets, goes back into the short block and fills this whole passage in the back of the short block, and then exits right there as I pull back. So that's where coolant exits. It exits out the top of your short block. And that port is right there. That actually goes to your crossover pipe. That crossover pipe connects to your other side, so your right side head and your left side head connect to this crossover pipe. That's actually also where you have your temperature sensor for your coolant system. And then that crossover pipe, like I have on this diagram over here, that crossover pipe goes back to the top of your radiator to pass through those radiator fins and to get cooled by that ambient air. Okay, so let's jump over the head and let's talk a little bit about how the coolant passes through the head, because that's a key piece to this whole system. That's the whole reason why these reverse cooling mods are on the market. Okay, here's the left side head for this EJ205 engine. This is the bottom of the head. This is actually the surface of the head that mats to the engine block and has a head gasket that sits against it. This is the top of the head, and this is actually where that intake manifold and those TGVs will bolt up to. Now remember, these head gaskets sit between the cylinder heads and that short block, and these head gaskets are actually going to be the smallest restriction point for the flow of that coolant from that lower passage that's in the short block through these little kidney-shaped restrictions into your cylinder heads. And if I lay this cylinder gasket up against this cylinder head, you can get a better idea of how it sits and where those coolant passages are. Coolant is actually coming out of these kidney-shaped slots. Remember, this lower portion, that's actually for oil drain back. So there's no coolant going through this slot or through this slot right here, and there's no oil or coolant going through any of these portions. These are actually where all the head studs, where all the head bolts are, these round portions right there. So the only place where the coolant is passing through this head gasket is through these little kidney slots right here. And this head is oriented correctly for up versus down. This is the bottom of the head. These are the studs where the exhaust manifold screws up to, and this is the top of the head. So these are actually the bottom ports where the coolant fills up in the short block and then enters through these little kidney-shaped slots and then goes into the head and then passes through the head and then comes out these top slots right here and then goes back into the short block, exits short block, into the crossover pipe, and then goes over to the radiator and then gets cooled through the radiator. Now the first thing I want you guys to notice is that these kidney-shaped little slots in this head gasket are definitely a restriction to coolant flow. If I remove this head gasket, you guys can see those slots are actually quite a bit bigger than the slots in that head gasket. If I wanted to, I could carve this one open all the way down to this point right here that I'm outlining with my little pointer, and this one can get carved out just a little bit wider as well. If I pull this up, you can kind of see. Look how much bigger this little slot is than the little slot that's in the head gasket. That's the slot that's in the head, and this is the slot that's in the head gasket. And remember, the short block has a big open passage, so this is really the only restriction, is the head gasket. And then if we look over here, this right here is quite a bit larger cross-sectional area than this area. So that means we're going to get a lot more volume, a lot more flow through this passage than this passage right here. And if we open this one up to be the same size as this passage, we'll actually flow more coolant into this head. And as long as we can flow the same volume of coolant out of the head, we're actually going to be allowing more volume of coolant to flow through the head. And that's definitely going to be a good thing. And that's definitely going to cool the head. So I'll be honest, guys, I'm seriously considering shaving these head gaskets to open up these ports, because you can actually open up the bottom ports on both sides, and you can open up the top ports. And what I'm going to do is I'm going to calculate about how much I open up the bottom port. That way I can open up the same percentage up on the top ports, and I can open up all, I guess, 8 of these ports, 4 on this side and 4 on this side. That way I'll have more coolant that can get from the bottom of that short block through this head gasket into this head, and then back into my short block and out into the radiator. Okay, so the next step is to take a closer look at how coolant actually flows through this head. And I'm going to take a close-up view of that. I'm going to bring my light back over into this head, and I'm going to shine that light into this head so we can get a better idea of where the coolant is flowing through these ports. Because for most people, we really have no idea of exactly where the passages are in these Subaru heads. This is the left side head, which means it's cylinder number 2 and number 4. Number 2 is in the front of the engine, that's this side of the head, and number 4 is in the back of the engine. So this is cylinder number 4, and this is cylinder number 2. And you can always tell that by where the camshafts are. There's no camshaft sticking out on this side, so this has to be the back. Now this reverse cooling mod actually taps into this plug right here on the back of cylinder number 4. And I've already loosened it, so I can take it all the way out for you guys. Boom. I'll take the camera off so you can see a little bit closer of where that port goes. And I'll shine the light in there so you can get a better idea. Okay, you can't see very much. You're basically just seeing into the back of the combustion chamber, but it goes in about an inch and a half. And that's actually right against the backside of that combustion chamber. If I zoom out, you can see that's where the valves are, and that's where the combustion event's taking place. And when I have that light in there, you can kind of see the coolant chamber in the back right there. And I can shine the light through this chamber. You can kind of see how it goes in there, kind of webs around, back behind the head. And it go right here, you can kind of see the webs in right there, right? And the same thing down here. So all these passages right here are all connected just a little bit in this kind of complex little casting void space behind the combustion chambers. And again, coolant enters through these bottom ports, through that lower portion of the short block, enters through these bottom ports. They pass into the ports, positive pressure, get pushed in through here, gets squished everywhere behind the head, and then ends up coming out through the two kidney shapes in the top, back into the short block. So that's coolant coming out in this direction towards us, goes into the short block, and then goes out through that little port that goes to your crossover pipe. But where that exit port and where that crossover pipe is actually part of the problem. If you think about it, coolant is actually coming in right about here in the front of the engine where cylinder number 2 is. Remember, this is cylinder number 2 and this is cylinder number 4. Coolant comes in right here, fills up this whole lower chamber, and then passes in, goes around the head, and then goes back into this chamber right here through the head gasket, and then comes out right through this chamber into the crossover pipe and over to your radiator, right? What happens is because there's an inlet point right here, which is where the highest pressure point is, and the exit point right here, which is where the lowest pressure point is, you actually create preferential flow paths from this point through the head out to this point. Coolant in all liquids, this comes from fluid mechanics, all liquids basically follow the path of pressure differentials. Pressure differentials are really what drive the flow of fluids. And the pressures in this system are really at the highest point right here and at the lowest point right here where the coolant exits. And anytime you have fluids where the maximum pressure differential is from one point, point A, to point B, that's where you're going to have preferential paths develop. And that's exactly what's happening with these Subaru motors. And that's also exactly what these reverse cooling mods are actually aiming at addressing. These reverse cooling mods actually install a point in the back of cylinder number 4, which is actually, if the cylinder head is sitting on the engine, cylinder number 4 is on the back of the engine, which is over here. They actually tap into the back of cylinder number 4 and they allow coolant to exit cylinder number 4 and get sucked into the water pump. And what that does is that actually creates a second negative pressure point for that flow. And if you think about fluid mechanics and the way fluids flow, if you create a second negative pressure point, you're actually going to create more flow from the inlet point over to the exit point because you actually have another low pressure point where the coolant can exit. So you'll have flow over to that point and you'll have flow up to this point to the crossover pipe. And that's basically the fundamental concept of these reverse cooling mods. So what is it with the cylinder number 4? Why does this particular cylinder have a problem in these flat 4 Subaru motors? Well, there's several reasons that these cylinders have problems. And the fundamental reason that these reverse cooling mod kits are even on the market is because over the years, it's become clear in the Subaru community that cylinder number 4 has a disproportionate number of cylinder failures. Basically, cylinder number 4 seems to be one of the weak links in these Subaru motors. And a lot of people have found that when you start pushing these motors, you start making higher horsepower and you start running more aggressive tunes, that the first cylinder that goes is that number 4 piston. And a lot of time, it's the ring lands in that piston. If you have internal damage to your engine, it's probably going to be cylinder number 4. Now why is that? Now I'm not an engine tuner, and a lot of the reason has to do with the fuel maps and the ignition maps that tuners run on these engines. So I can't speak to that with any authority. But one of the fundamental reasons that cylinder number 4 is a problem is actually where the knock sensor is located. The knock sensor on the EJ series of these Subaru flat 4 motors is actually located right over cylinder number 4. And because of that, the knock sensor actually picks up the knock signal from the number 4 combustion chamber stronger than any other combustion chamber. And that's also the reason that the factory ECU is programmed to have a slightly more aggressive tune for the number 4 cylinder. That way, if you have a bad batch of gas or if you have any other issues with the air-fuel mixture, cylinder number 4 will be the first one to knock, and that knock sensor will always pick it up first. And that way, the ECU knows to retard the timing, to bring it back. That way, it's not going to damage any of the other cylinders. So essentially, the strategy for the ECU programming in these cars is basically to use number 4 as a guinea pig, and anytime there's an issue, that cylinder and that piston is going to be the first one to see it. And the second factor is definitely going to be the location of cylinder number 4. I think this is going to be a lot less of a factor than the NOx sensor and the fuel maps and the timing maps that are used. But the fact that cylinder number 4 is located behind cylinder number 2, and the cylinder number 2 is exposed to that fresh incoming ambient air from the front of the car, that leads me to think that cylinder number 2 might get a little bit more cooling just being in that location. But one of the biggest factors is actually the way the coolant flows through the cylinder head. That coolant is doing a majority of the cooling of that combustion chamber. As a matter of fact, that coolant is doing almost all of the cooling of the combustion chamber. Some of the cooling takes place from heat transferring through that aluminum head and radiating to the ambient air, but most of the cooling, and I wouldn't be surprised if it was 95% of the cooling, takes place from the coolant that circulates through this head. So the way the coolant flows through the head is actually key to controlling the temperatures that build in those combustion chambers. And that's what this video is all about. We're taking a deep dive into how the coolant flows through the Shortblock and flows through these heads. To illustrate that in a really creative and interesting way, I'm actually going to grab a transparency and a marker, and I'm going to sketch out exactly where the cylinder flow is through these cylinder heads, and I'm going to give you guys a little bit better idea of how the coolant flow is taking place inside the chambers of the cylinder head. Okay guys, this is going to be interesting. I'm actually going to use one of these head gaskets. I'm going to use that as an outline for the coolant chambers and for the combustion chamber. And I've actually just got one of these clear transparencies. I'm going to use this sucker to outline the image. And then on that, I'm going to go ahead and actually draw flow lines, equal potential lines. And I'm going to explain what those are when I get to that point. Okay, the first thing I'll do is I'll put this transparency down. I'll go ahead and tape it in place. That way I don't have to worry about it moving. Alright, and then I'll go ahead and grab that head gasket. I'm going to set that down. I'm going to use this as a template. Now, I know this is a head gasket and not the cylinder head. I know this isn't the exact location for all the ports inside the cylinder head, but this is going to be a really nice approximation of where all the ports are in that cylinder head. So I'm going to go ahead and use this as a template, a couple pieces of tape down, and then grab my Sharpie and go ahead and mark it out. So I'm going to go ahead and mark everything just using the head gasket as a template. And I'll go ahead and get the internal combustion chambers. And continue to trace out where the coolant passages are in this head gasket. And trace out exactly where the coolant flows. Okay, now what do I got here? This is definitely a decent outline of that head gasket. And as you can see, I got kind of the chambers of where the coolant can flow. This is actually your combustion chamber. Coolant is entering these ports, flowing through the head, and then exiting out these ports. But what's controlling that is where the coolant enters in the Shortblock and where the coolant exits in the Shortblock. So I'm going to go ahead and mark those locations on this figure next. Okay, for these, I'm going to go back over here to the engine. I'm going to kind of lay it down here on top of the Shortblock. And I can kind of see exactly where that coolant enters. So I'm going to go ahead and grab that light. I still have the plug removed on the bottom of the Shortblock, and I can put that light right in where the coolant is entering. And then I can go ahead and mark on this figure exactly where this port is. And I'll go ahead and do the same on the top where the coolant exits. I'll just kind of mark on the figure exactly where I know that port is exiting. Okay, we'll go ahead and take this back over to the workshop bench. Okay, so this is where that port is entering the Shortblock underneath the head gasket and the cylinder head. So this is going to be the highest pressure point. Even though it's filling that whole chamber in that Shortblock, the fact that the coolant is entering over here and it's actually deflecting off that cylinder wall, this is actually going to be the highest pressure point for all the coolant that's going through these little kidney-shaped passages through the head gasket and into the head. So we're going to call this our highest pressure point. I'll put a little arrow and a P for pressure. And then over here, that's where it's exiting the Shortblock. So that's going to be the lowest pressure point. So I'll put a P and a down arrow for low pressure. So we basically have coolant coming into the head from these bottom ports, like we've talked about earlier in the video, and we have coolant passing through the head and then exiting on the top half of the head, going back into the Shortblock. So I'm going to draw little arrows kind of coming out of this port, this little kidney shaped slot. And I'm going to draw little arrows going in to this guy. So the flow is going into these ports. a lot of arrows. I think you guys get the point with the arrows. And what actually happens is you actually have something that calls flow lines develop. And what that is that from every point that's coming out of this little shape, it's going to want to go through this passage and then exit over here. And it's going to kind of look like this. It's going to be a nice smooth path. Now there'll be some turbulence. They'll kind of go in nice smooth flow lines. And these flow paths come out of this like little port perpendicular. And then they flow, and they flow, and I know there's going to be some different obstructions in there. This is a general idea of how the coolant is going inside that head. Alright, and eventually you get something that looks like this. And this is a really rough, crude sketch of the flow paths that might be taking place inside that head. And I think the ports are a little bit constrained and are a little bit smaller than this, quite a bit. This is actually two-dimensional, not three-dimensional flow. You're looking at a 2D flow field is what it's actually called. And these are actually called flow lines, and the arrows are kind of showing the general flow field. And what this basically shows is how coolant is entering through these lower kidney slots down here, and it's entering the head, and it's making its way through preferential flow paths that are based on pressure differentials. So basically, each one of these points where the coolant enters the head is going to want to go to the point where it can exit the head at the lowest pressure. So basically, this flow path right here will be exiting right here or wherever the lowest pressure point is. This is basically an even symmetrical flow field, and that would be if we had even pressures coming in the bottom and even pressures going out the top. But that's not actually what's taking place. If you recall, we actually have high pressure right here and we have low pressure right here. So what that means is you're actually going to have a skewed flow field. You're going to have a flow field that actually goes preferential from this point right here where the high pressure is to that point right there where the low pressure point is. So you're going to have a lot stronger flow paths between these 2 points, which means all the flow around here and all the flow around here on this cylinder. And what you're actually looking at is over here, this is going to be cylinder number 2, and this is going to be cylinder number 4. So when you consider that preferential flow path from the high pressure point to the low pressure point, you can see really clearly the cylinder number 2 is definitely going to have a whole lot more coolant circulating around it. And as a matter of fact, cylinder number 4 is going to have very little coolant circulating all the way around it. There's going to be a lot of coolant flowing on this side of cylinder number 4, but really down over here on this side of cylinder 4, you're going to have very little coolant flow because you have this preferential path going from here to here. Now what those reverse cooling mod kits do is they actually add a negative point right here, or they let the coolant exit the back of the head, and they tie that into the heater core circuit, which gets sucked by the water pump and gets recirculated. So they actually induce a negative pressure point right here, just like we have up here, which means you actually start getting flow paths from this point and from this point, and slight flow paths from here and from here, which means you're starting to pull a lot more coolant over to that number 4 cylinder head. It also means that if there's a lot of stagnant flow over here, and the fact that there's so much flow going from here and here means it's very possible that there's very little flow coming from here and very little flow over here, and there might be a lot of stagnant coolant that just sits there and gets baked and absorbs a lot of heat that gets built up in cylinder number 4. So I think the fact that they're creating this exit port in the back of cylinder number 4, and I'll mark that right now. Now you're actually going to induce flow to the back of cylinder number 4. You're going to get rid of any stagnant coolant that may have been sitting there, and a lot better control of the temperature that develops in cylinder number 4. And that is key because, like I said earlier, cylinder number 4 seems to be the Achilles heel for a lot of piston damage in these Subaru engines. Alright guys, a little bit of reflection. This kind of gives you a 3D representation of how that flow field might be occurring inside those heads. Right here, you have the inlet port, and that's where the highest pressures are, so you're going to have the highest pressures coming out of these 2 slots into the head, and then from there, you're going to have fluid that creates these preferential flow paths, kind of like what you're seeing here. Now remember, the flow field you're looking at right here would be for a completely symmetrical system, with equal pressure at all 4 slots, and equal pressure at the top, and that's not the case. In reality, these flow paths will look a little bit different. There's going to be really strong flow paths right to the middle, going from this point over to that point. It's maybe something you guys have never seen. It's not something I've ever seen. I think it's kind of cool. Okay guys, now that we've walked through how coolant flows through the short blocks of these engines, and we've taken a really deep dive into how the coolant flows through the heads of these engines, I think you guys can start to see why it appears that cylinder number 4 is actually getting inadequate cooling with that factory coolant design for these engines. And that's why these reverse cooling mod kits that are on the market might actually be a really, really good idea to provide some protection for your engine and to maintain more even cylinder temperatures across all 4 cylinders. Like I mentioned earlier, the number 4 cylinder and the number 4 pistons actually see a disproportionate number of failures with these Subaru engines. And it's pretty clear in the Subaru community that that number 4 piston is usually the first piston that's going to fail. So what you're looking at in front of me are 2 of the reverse cooling mod kits that are on the market. This one right here is a VEMS tuning kit. This sells for about $90 and it got to me in just a few days. And then this one right here in front of me, this is actually the Get a Dom tuning kit. And I'm going to go ahead and do a little bit closer comparison of each of these kits, and then I'm going to walk through installing one of these kits on my engine. As you can see, I've actually installed the other head on this engine, and I've also installed these coolant pipes on the engine. That way, we can walk through exactly where and how these reverse cooling mod kits are installed on this engine without any of the other obstructions like the intake manifold or the engine bay. Okay, let's start with this kit on the left. This is the VEMS tuning kit. This is exactly what you're going to get in the mail if you order this kit, and like I said, it's about $90. This is the main part of the kit. This is a hose that's going to tie into the back of that cylinder number 4 head, and this is actually the plug that's going to screw into the head. And then they have a T on this side, and this is the side that ties into that heater core circuit. And from there, it gets sucked into your water pump. The first thing you'll notice is that pretty much all these parts are off-the-shelf parts. You can pretty much get this part in any auto parts store. This is just a standard high-pressure hose. These are just standard stainless steel crimps, although I have to mention they are high quality and they're stainless steel, so that's a good thing. And then this right here, this billet anodized fitting, this is actually an off-the-shelf part from a company called Phoenix Industries, and they actually even have their little logo right there on it still. So VEMS is definitely sourcing their fittings from this company called Phoenix Industries. And as a matter of fact, I've actually used one of their fuel pressure regulators, and they're a high quality company, and I definitely like their products. But it's definitely not made in-house by VEMS. And this baggie comes with the kit as well. This actually has 2 hose clamps and a little fitting. And this is a fitting that actually screws into the back of that cylinder head. And I'll take that out right now so you can see a closer look. I'll also mention that these hose clamps look like they're stainless steel. Okay, here's that little fitting. And again, this is from Phoenix Industries. So VEMS is sourcing this one from Phoenix Industries as well. It's got a little crush washer on it. That should help seal it. But I'm pretty sure in the instructions they'll probably have you put a little RTV in here. I don't know, we'll see. I definitely would. Add a little high temp gray RTV. And then on this side, this is actually what's called an AN fitting, which stands for Army Navy, I believe. And that actually screws into this port right here, right? So those two will screw together like this. Boom. And then this goes into the back of the head. And then here's the instructions they send. They talk about the problem, the solution, and then if you flip it over, this is where they walk you through installing the kit. They talk about the benefits, the needed tools, the pre-install inspection, and they walk through right here how to install it, and they have their contact information on the bottom. So that's pretty much the instruction from VEMS Tuning. No pictures for the installation. All you'll see is a little bullet list right there for the instructions. So that's not all that ideal, but hopefully you guys can look some videos up or you're watching this video, so this is going to walk you through it. And this one over here on the right, this is actually the Get a Dom tuning kit. And I have to say, right off the bat, these are a much nicer kit. It's a much higher quality kit. You can see the fittings are just a lot cleaner and a lot more smoothed off. I really like the gold anodized look. I think there's a company called Beat Rush out of Australia that has a lot of gold anodized parts like this, so this would be a nice compliment for those parts if you have them on your Subaru. This also has a stainless steel clamp right here. This is like a factory clamp. It's got rubber hose. It comes with this little stainless steel T-fitting, and this is what you use to tie into that heater core circuit. And then it comes with a few hose clamps. Those hose clamps are basically used to tie in this T-fitting. And then for the Get a Dom tuning, at least he has a picture. The VEMS kit didn't even have a single picture. So Get a Dom tune kit definitely has a one picture. That's nice. And then right here, they walk through all the steps to install it. And they actually have a little outline of the fitting right here. So this is actually used to trim that hose for certain applications. Okay, so if we're going to compare these two kits, what do they really look like? Well, as far as the T-fitting is concerned, they're virtually the same thing. I believe they're both a 5/8 inch or something equivalent, and they're just a T-fitting. One thing I'll mention is you might get a little bit better flow through these T-fittings if you swapped them out for a Y-fitting. I think the real difference is actually in the fitting that screws into the back of the head. That's where the Get a Dom Tune kit clearly has a much higher quality part, which means he pretty much designed it from scratch and he's having them custom made, unlike the VEMS kit that basically just sources parts available from the shelf. And to be honest, you guys could literally put together the same kit that the VEMS kit has right here. And then the other thing I'll mention is that it's not very easy to see with the light, but the Get a Dom Tune fitting actually has a quite a bit larger interior diameter for the port that's exiting the head, which means that more coolant is going to flow through this kit. And that means you're actually going to have more cooling for cylinder number 4 with this kit. So I got to be honest, based on the quality of the parts and the design, I think this Get a Dom kit is actually a better kit and it's going to outperform the VEMS kit. And that's really what matters to me the most. Okay, let's go ahead and grab that Get a Dom Tune kit and let's walk through the installation on this EJ motor. Okay, we're here on the back of the engine. This is the left side of the engine, the left cylinder head, which is cylinders number 2 and number 4, and we're going to go ahead and remove that little plug right there. This is the plug that goes into that cylinder head and taps into that coolant passage right behind the combustion chamber. So we go ahead. Oh, damn. Don't do that. That's what you don't do. I know some of you guys out there are probably going to want to go ahead and try to make this yourself. Alright, I actually have my little sizing gauge, and I'll show you guys the size of this plug using the sizing gauge. Basically right there, it's an M20. That's the plug size, and then go ahead and screw it in. I didn't read the instructions, but you're probably going to want to put a little RTV on this. You can use that Ultra Gray, or you can go ahead and use the Subaru OEM RTV. So that's basically the idea. You're going to tap it in right there to the back of cylinder number 4. Okay, then we'll go ahead and grab that T-fitting, and we'll connect that to this rubber hose that we screwed in. Now you're going to have to read the instructions, but for certain makes and models, you're actually going to trim this hose. And go ahead and trim this hose down to the length that's shown at the bottom of that instruction sheet. But for right now, I'm just going to go ahead and do a mock installation for you guys. And you'll need to put on one of those hose clamps, so don't forget to install those suckers. And this sucker goes around and is going to tie into your heater core circuit. And you want to tie into this black hard pipe, and I'm going to put a little hose section right there to connect the two. As a matter of fact, I actually have a hose right here I can use, just to kind of show you guys what it looks like. And then I can step back and zoom out, and you can follow this circuit back to the water pump. So you go ahead and take this sucker, and that's going to connect in there. And of course, you're going to have those hose clamps on all these fittings. Okay guys, and if you follow this black hard line down along the engine, you can actually see how it weaves down along the front of the engine, through a couple of hoses, and then ties into the water pump, right there on the front of your engine. And remember, this cavity down here is where that thermostat is, and where that fresh cold coolant is being drawn into the water pump and pumped through your engine. So that's pretty much what this sucker looks like when it's installed. It goes into the back of that cylinder number 4 port. Okay guys, I know you thought we were done. I know we've taken a deep dive into Subaru coolant flow. I know we've looked through every little facet of how coolant flows through the heads of this engine. I know we've looked at flow nets, we've looked at transparencies that are folded up on this engine. We've looked at all kinds of crazy stuff today. But there's one more thing we gotta talk about, and that is the exhaust port configuration for the right head versus the left head on these Subaru engines. When you look closely at the design of the exhaust flow paths, what you're gonna see is for the back 2 cylinders, which is cylinders number 3 and number 4, those 2 cylinders actually have different exhaust port configurations. Cylinder number 3, which is oftentimes right by a turbo, actually has a straight through path for the exhaust ports to exit the combustion chamber and then get into that header. Whereas cylinder number 4, on the other hand, has a totally different configuration for the exhaust port path. The exhaust port on cylinder number 4, which is the other rear cylinder on these flat 4 Subaru motors, that port path actually slams right into the cylinder wall, has to make a right turn and then another right turn to exit the cylinder head. And I think that all that heat energy and all that kinetic energy is slamming right into the cylinder wall and having to make a turn and then another turn to get out of the exhaust port and then into the exhaust manifold actually adds a lot of heat to that portion of the cylinder head. And I'm going to rotate this engine so you guys can see exactly what I'm talking about. In this right head, this is actually cylinder number 1 and number 3. A lot of times there's actually a turbocharger sitting right there, so there's tons of heat building, and yet cylinder number 3 doesn't seem to have the problems that cylinder number 4 has. And I think a big part of that is the coolant flow through the heads, but it's also the exhaust port configuration. And with the engine rotated like this, we can take a closer look at how the exhaust ports are configured. And what you're looking at is actually the exhaust ports for both sides of the right-hand cylinder head. And that is the exhaust ports for cylinder number 1 and cylinder number 3, which means there's going to be 2 exhaust valves inside each one of these ports. And as you can see, both these exhaust valves for the number 3 exhaust port actually have a straight through shot right out of the exhaust port into the header and down through your exhaust system. Cylinder number 1 is the one that actually has that right angle that the exhaust ports have to go through. And if I zoom out, you can think about where the spark plug is located. The spark plug is located in the exact center of the combustion chamber. So that means the center of this point and the center of this point is actually where the combustion chamber is. So over here, the center of the combustion chamber for cylinder 3 is actually right here, and if you look straight down, it actually goes right down to this exhaust port. Over here on number 1, if you go straight down, is actually over here. Cylinder number 1 would want to exhaust right here if it was lined up with the port. But it has to make a right turn over here and then another right turn to exit out your exhaust manifold. And that means that the exhaust gases from cylinder number 1 are adding a lot more heat to the cylinder head because those exhaust gases are slamming up against the inside walls and having to redirect direction and then slam up against that wall and then redirect direction again. So all those exhaust gases that are full of heat and that are full of kinetic energy are transferring that heat and kinetic energy into that aluminum head. Now it's cylinder number 1 and 3. If we go down here to cylinder number 2 and 4, it's actually a totally different story. This is cylinder number 4 and this is cylinder number 2, which is in the front of the engine. If you look at cylinder number 2 actually is a port that has a straight through shot. Those are the exhaust valves for cylinder number 2. If you move over to cylinder number 4, all you see is black right here. And that's because all the exhaust gases have been slamming into this sucker and putting a bunch of that carbon against the walls. So if I look at an angle, I can actually see one of the exhaust valves. Those are the exhaust valves. So just like we saw on the other head, the center line on the left head for cylinder number 4 is actually somewhere over here. And those combustion chamber gases exit the combustion chamber through those exhaust valves and then slam into this portion of the head. And have to make a right turn, slam into this portion of the head, and then come out of the exhaust port into your exhaust manifold. So guys, I think that's another reason that cylinder number 4 has all these problems. Not only does cylinder 4 have this fundamental flaw in the design of the coolant system, the exhaust gases slam into the walls of the cylinder head and actually transfer a lot of heat and that kinetic energy into the walls of the cylinder head. Right down this portion where the cylinder head is not actually getting a lot of flow. Those two factors in combination, guys, is why I think these Subaru engines have so many problems in cylinder number 4. And that, guys, is why you seriously want to consider getting one of these reverse cooling mod kits for your Subaru. When you introduce a negative pressure point or an exit port for the coolant on the back of that cylinder number 4 coolant chamber on these Subaru heads, you actually introduce a lot more flow to that cylinder number 4, which will actually cool that cylinder number 4, and in theory, it could be solving one of the fundamental inherent design problems with the cooling system on these Subarus. So I think this is a critical upgrade for any Subaru, especially Subaru that's going to be making higher horsepower or running aggressive fuel and ignition maps with their Subaru. I hope you guys enjoyed this video. I hope it gave you a better understanding of how coolant flows through these Subaru engines, and I hope it gave you more insight into how coolant flows through the heads of these Subaru engines. And I hope it gives you a better idea of whether or not you want to seriously consider purchasing one of these reverse cooling mod kits for your Subaru. So thanks so much for watching the video, guys. Thanks so much for supporting the SubaruONLY channel. If you have any questions or comments, please leave it in the comments section. I'm definitely going to be getting back to you guys. But for now, I want to say thanks so much, guys. This is the SubaruONLY channel. Until next time, guys. Later! So this begs the question, guys, why in the world did they actually cast the heads this way? And I gotta be honest, I've looked these heads over from the inside, I've looked at the valve train components and all the ports and passages for the valve train components, I've looked at the coolant port and passages, I've looked at the oiling ports and passages, and to be honest, I don't think there's any reason why these Subaru heads couldn't have been cast with these exhaust ports in a symmetrical fashion. And what I mean by that is both of these Subaru heads have one of the cylinders where the exhaust port has to make a quick right turn and another right turn so that both of these exhaust ports can be close. And I suspect that part of that is in manufacturing and cost savings. I think that Subaru probably found it a lot cheaper to manufacture exhaust manifolds with both the exhausts right next to each other. And that makes sense. When you're mass producing cars, you have to make certain sacrifices. But I gotta tell you guys, I don't think there's any reason why a company that manufactured heads couldn't actually design a Subaru head where these exhaust ports were completely symmetrical with the combustion chambers. That way you'd have one exhaust port right here and you'd have the other exhaust port right here. and you'd have it on the other head as well. And that way, these Subaru heads would actually flow a lot more evenly, and all the heat that gets distributed into these heads by those exhaust gases would actually be distributed into the heads a lot more evenly, and a lot less of the heat would get into the heads. So if I owned a company, guys, or if I was on the R&D team for an aftermarket parts company, I would love to have the project where we redesign these Subaru heads and we actually design a set where we have the exhaust ports completely symmetrical. That would be legit, and that would totally change the game for these Subaru engines.